When dealing with interval notation, I find it easier to show students how the interval notation connects to the number line and then how it connects to the interval notation. So we're going to start with this inequality. This first one, x greater than 5. Well, that means it's everything above but not including 5. So here on the number line, we're looking at all of the numbers bigger than 5. As an interval notation, we would write that an open parentheses 5, comma, infinity, because our number line is not including 5, so that's why it's a parentheses, but it's going all the way to the right to infinity. Now, if we look at x less than 5, well, here on the number line, it would be everything below 5, but not including 5. And so on the number line, we see it's everything from negative infinity, down here, up until 5. So in interval notation, it's negative infinity to 5. You're always going left to right, smallest to largest, and you're always going to infinity or negative infinity when it's just a greater than or a less than or a greater than, less than, or equal to kind of problem. The last one where it's in between, you won't have an infinity. The only thing that changes when you have this little bar underneath your inequality is that just says that it could also equal that number. So here, x greater than or equal to 5 would be everything from 5 above, and we would indicate that with our interval notation with that closed bracket, 5 comma infinity. And then same if it's less than, starting at negative infinity and going up to 5. So it'll look like that for any of these basic inequalities. When you have a compound inequality, again, think of what this would be on the number line. X is between 1 and 5, but it does not equal 1, but it could equal 5. So here, our interval would be open at 1, comma, 5, closed. And that's just saying that everything between 1 and 5, don't include 1, but include 5. On number 6, when you're dealing with domain, there are 3 things that we need to know about domain. If it's a polynomial, okay, so polynomial where you just have x's and numbers and powers of x's, but there's no division, there's no square root, none of that. Your domain is always all real numbers. And we would write that negative infinity to infinity in interval notation. So anytime you have a polynomial, just x's and numbers, nothing crazy, the domain is all real numbers. But when you have a radical, when you have square roots, you cannot take the square root of a negative number. So if you have an even root, so square root or a fourth root or a sixth root, you take whatever is under the radical. So let's say it's x plus 3. You take that argument under the radical, it's called the radicand, and you set it greater than or equal to 0 because you need whatever is under that square root to be positive. Now, even if there's stuff outside of the square root, that doesn't matter. Just what's under the square root matters. And then we solve this inequality here. We'll subtract 3, and we get x greater than or equal to negative 3, which, using what we did on the last slide, that would be everything from negative 3 to infinity. Feel free to draw a little number line to help you with this. That connection, I think, really does help tremendously with these intervals. Now, there is one thing when you are solving the one in the homework. Here, I'm going to do different numbers, but if you had square root of 5 minus 3x, when you set that greater than or equal to 0, first you'll subtract the 5. But then when you divide by negative 3, don't forget that that's going to actually flip your inequality, and that would make that a less than. So just be cautious on that. But on radicals, it's always whatever's under the square root. You set that greater than or equal to 0, and that becomes your domain. The last type that we need to deal with are the rational functions. So you'll have some function over some function. And with these rationals, we cannot divide by 0. It's one of the rules of math. We can't divide by 0. There's no way to divide something 0 ways. So we're going to take what's ever in the denominator and make sure that it's not 0. So let's say we had 5x plus 2 over 3x minus 4. So here, the only thing that matters is that this 3x minus 4 cannot equal 0. So I'll solve this equation. I'll add 4, divide by 3, and so x cannot equal 4/3. So that is the one value that would make this denominator 0 and would cause a problem. Well, if we thought about this on a number line, it's everything except for this value. So it's everything above, everything below, just not 4/3. So the way we would write this in interval notation is we would start at negative infinity. We would go up to 4/3, but we won't touch it. So we'll use the open parentheses, and then we'll union from 4/3 to infinity. So it's kind of like breaking this into two pieces, and that little u represents the union of these two intervals. And it says, hey, together these make the entire domain, but we do need to skip over this one value, and so we'll break it apart right there. So hopefully that helps with your domain. Polynomials, all real numbers. Radicals, what's underneath the radical, set it greater than or equal to 0 because you can't take the square root of a negative. And on fractions, set the denominator not equal to 0 because you can't divide by 0. And so that's the value that we need to skip over.